Hello students, welcome back to YouTube channel of Saint Wilfred College. Today we are going to talk about the heterocyclic compounds. Okay, first of all, for that we need to know about the heterocyclic chemistry. Okay, so let's start with heterocyclic chemistry. First, the cyclic or a ring compound which contain at least one atom other than the carbon atom. Okay, it's called such as a nitrogen, after that oxygen, sulfur, selenium, phosphorus, silicon, boron, and arsenic as a member of a ring are known as a heterocycles or heterocyclic compound. Okay, what happened? There will be a ring structure in which the carbon atom, one or more carbon atom are replaced by the heteroatom. That compound will be called as a heterocyclic compound. After that, the atom other than the carbon atom are known as a heteroatoms, and they are classified on the basis of a number of ring. After that, ring size, number of heteroatom, and type of heteroatom. Okay, next one, heterocyclic compounds form an important class of compounds because many natural products such as the drugs, dyes, etc. contains heterocyclic ring. After that, the heterocycles may be saturated or unsaturated. It should be aromatic or non-aromatic. However, we shall discuss all that thing afterwards. Okay, there are some common heteroatoms such as a nitrogen, after that oxygen and sulfur, which we are going to see in 5 and 6 membered ring system. There are main four heterocycles such as a pyrrole, after that furan, thiophene, and pyridine. Pyrrole, furan, and thiophene, these are the 5 membered heterocyclic compound, and pyridine is an 6 membered heterocyclic compound. Today we are going to see about the um, nomenclature of a heterocyclic compound. But for that, first we need to know about the heterocyclic compounds, right? So the compound which are classified as heterocyclic probably constitute the largest and the most varied family of organic compounds. After all every carbocyclic compounds, regardless of a structure and functionality, may in principle be converted into the collection of a heterocyclic analogous by replacing one or more of the ring carbon atom with a different element. Okay, after that, if we restrict our consideration to oxygen, nitrogen, and sulfur, which are the most common heterocyclic element, as I said, okay, the pre-mutations and the combination of such a replacement are numerous. After that, we will start with the nomenclatures. There are some rules, IUPAC rules for nomenclature. There are three systems that we are going to use to name the heterocyclic compound. First one is the Hatch-Widman nomenclature. Second one is the common names, and third one is the replacement of a nomenclature. Okay, first we will go for the what is means of nomenclature. First we need to know what is nomenclature. Okay, so let's start. Devising a systematic nomenclature system for a heterocyclic compounds presented a formidable challenges, most of the time which has not been uniformly concluded. Many heterocycles, especially amines, were identified early on the received tribal names. Okay, after that, which are still preferred, and some monocyclic compounds of these kinds are shown in the following chart. Next, we are going to see that chart with the common name means as a tribal names. Okay, in bold, and systematic names on the basis of a Hatch-Widman system. Next one, the rule for using this system will be given later for most an easy to remember but limited nomenclature system make us an elemental prefix for the heteroatom, which are followed by the appropriate carboxylic name. First, we have to start with a short list of some common prefixes. We are going to discuss it on today. Okay. First, let's see about the Hatch-Widman system. Hadge-Widman nomenclature. In Hadge-Widman nomenclature, that system provides us a more systematic method of naming heterocyclic compounds that is not dependent on a prior carbocyclic names. It makes use the same heteroatom prefix defined above, followed by a suffix designing ring size and a saturation. Okay. After that, as outlined in the tables, each suffix consists of a ring size. First, we are going to see ring size of the compound. After that, as we said that this Hatch-Willman nomenclature, it is always based on the type. First, which type of this compound. After that, which type of the heteroatom is present. And next one is the ring size of that compound. Is it is a two-member ring? Sorry, three-member ring, four-member ring. Okay, and last one is the nature of the ring. Is it is a saturated ring or unsaturated ring? Okay. After that, this system nomenclature applies to monocyclic 3 to 10 member ring heterocycles. We can apply this Hatch-Willman nomenclature system to monocyclic to 10 membered heterocyclic compounds. Okay, let's go for the next, which is a types of heteroatom and their prefixes. So let's see. First heteroatom is your oxygen atom. Okay, and if your oxygen is present in your ring, then you are going to call it as a oxa, or you are going to give a name that compound with the start with oxa. Okay, after that, N stands for nitrogen. The prefix we are going to use for nitrogenous compound, that is aza. Okay, next one is a sulfur. Okay, and the prefix will be thia. After that, phosphorus, and the prefix will be phosphor. Okay, let's move further. Okay, this one is a table which seem to indicate the ring size of heterocycle. If your okay, your nomenclature depending on the ring size. If your ring size is 3, means 3 compounds are there or 3 elements are there. The ring is made up of 3 hit 3 compounds, yeah, 3 elements. Then the suffix will be ir. After that, if the ring is a 4-member ring, then the suffix will be et. After that, if the ring is a 5-member ring, then the suffix will be ol. After that, if it is 6-member ring, suffix will be in, that is in. After that, for 7-member ring, suffix will be ep. For 8-member ring, the suffix will be oc. For 9-member ring, the suffix will be on or on. After that, for 10-member heterocyclic ring, the suffix will be ec. Okay, let's see the table 2, which indicate the ring size and degree. Means is it is a saturated ring or unsaturated. If we have a 3-member ring with a saturated compound, with a saturated form, okay, then we will give its suffix as a eren. Okay, if that ring is unsaturated, means if it contains the alternate double and single bond, then our suffix will be eren. Okay, next one, if it is a 4-member ring, 4-member saturated ring, then it is ethane, and 4-member unsaturated ring, it is 18. Okay, next one, 5-member ring with saturated 5-member saturated ring, the suffix will be olen and unsaturated for ol. After that, for 6-member, it will be enen and in. For 7-member, it will be epane, epine. After that, for 8-member, it will be osen and osin. And 9-member, that is onen and onine. And for 10, that is eken and isin. It is depend on the ring size as well as its saturation. If it is saturated, then, and if it is unsaturated. Okay, if we have saturated ring, which is a 3, 4 and 5 membered with nitrogen atom as heteroatom, then our suffixes will be iridine, etidine and olidine. Okay, for 3-member it will be iridine, for 4-member it is etidine, for 5-member it will be olidine. Okay, next one, all the suffixes, whatever suffix that we are going to use, that all suffixes consist a ring size. Okay, after that, whatever ending will be, it will be intended to designate the degree of unsaturated in the ring. After that, it is important to recognize the saturated suffix applies only to completely saturated ring system, and the unsaturated suffix applies to the ring in corresponding the maximum number of non-cumulated double bonds. After that, we have to see the system. Is it is a saturated or unsaturated? Okay. Then if it is a saturated ring, then 3, 4 or 5-member nitrogen heterocycles are there, then we should use traditional, that is a iridine or etidine or olidine as a suffixes. Okay. After that, there are some examples as like the terminal E in the suffix is optional though recommended. After that, if we are going for the saturated 3,5 member ring, as we said, we are going to use an traditional name that is a iridine. After that, iridine, olidine as a suffixes. Okay. After that, if there is an unsaturated nitrogen 3-member heterocycles, okay, we are going to use an traditional name that is a irine as a suffix. After that, consistent use of etene and olin as a suffix for a 4 and 5 membered unsaturated heterocycles. Okay. Next one will be one established use of oxime. After that, azine, silane for others compounds or functions. Prohibits their use for a pyran. After that, pyridine, respectively. Okay. These are some examples to how examples of a Hertz-Widman system. Okay, so let's see the first. It is an 3-member ring. Okay, 3-member ring, and it is an saturated ring. There is no double bond present here. So it is an saturated ring, 3-member ring. So the suffix will be even. And as we said, the heteroatom is oxygen, and for oxygen we are going to use oxa. So combining these two things, we will get its name as a oxyren. Okay, next one, let's see. It's also an 3-member ring, saturated ring. So eren and sulfur, and for sulfur this is a thia. So its name will be thia-eren. Okay, next one is 3-membered heterocyclic ring, which is a saturated, and our heteroatom is a nitrogen. For nitrogen we are going to use aja, and its suffix will be iridine. So its name will be aziridine. Okay, next we will go for the 4-membered ring. 4-membered ring containing oxygen atom and a saturated ring. Okay, for 4-member ring, saturated ring, the suffix will be ethane, and for oxygen it will be oxa. So its combined name will be oxetane. After that, next one, 4-member saturated ring, ethane. After that, heteroatom is sulfur, so we are going to use thia, and the combined name will be a thioethane. After that, next one is a again 4-membered saturated ring containing one heteroatom, which is a nitrogen. So we are going to use aza and etidine as a suffix. So we will get azitidine. Okay. Next one, let's see about a 5-membered saturated ring. Again, all are the 5-membered saturated rings containing first oxygen as heteroatom. It will be oxaolane. So its name will be oxolane. And after that, sulfur is a heteroatom. We are going to use only thia and olane for 5-membered saturated rings. So its combined name will be thioolane. After that, 5-membered ring saturated with nitrogen as a heteroatom, then we will get aza and olidine. So it will be an azolidine. Okay. After that, we will go with the next one, that is the rings with more than one heteroatom. Okay. If you have a ring structure which contain more than one heteroatom. Okay, if there are 3 nitrogen atom in one 6-membered unsaturated ring, then what will be its name? We are going to discuss it at here. Okay, let's see first. 2 or more similar atom containing in a ring are indicated by the prefixes. Okay, so let's see the first compound, that is a 6-member ring containing 3 nitrogen atom. As you are able to see that there are 3 nitrogen atoms, we are going to start numbering from 1 nitrogen atom. Okay, if we start it from this 1, after that this carbon will get a second number, this nitrogen will get at a third number, this one will get 4 number, and this one will be a 5 number, and this carbon will be a 6 number. So its name will be 1, after that 3 and 5, 1 3 5 triazine. Azine for 6-membered unsaturated ring. Okay, azine is an prefix which we are going to use, sorry, suffix we are going to use for 6-member unsaturated ring. Okay, and tri is nothing but an there are 3 nitrogen atoms, so we are using tri. Okay, and this 1 3 5 just indicate the position of that nitrogen atom. Okay, next one is a 5-membered unsaturated ring. Okay, in that there are 3 nitrogen atoms. Okay, if we start numbering from 1 nitrogen atom, okay, we will start from this nitrogen atom, then 1, after that 2 3 4 and 5. Okay, so let's see the name, that is the azole is its suffix because it is an 5-membered unsaturated ring, so its suffix will be azole. And tri is for 3 nitrogen atom. Aja will represent your nitrogen atoms, right? As we said that if it is a nitrogen atom, then we have to use Aza. OLE for the 5-membered unsaturated ring. Tri for 3 nitrogen atom, and 1, 2, 4 is nothing but an position of a nitrogen atom. After that, next, if more than one heteroatom occurs in the ring, then the heterocycle is named by combining the appropriate prefixes with the ending in table. Okay, let's see. In order of their preferences, means first to whom we have to give a number, or first if okay, let's see here, there are all same nitrogen atom there. Okay, only nitrogen atom there, so we are writing it like that. Okay, but if your ring have a 3 different heteroatom, then which one will you prefer first? We have to see that. So first we will prefer with oxygen, second one is a sulfur, and third one is a nitrogen. Okay, let's see the some example for that. Okay, let's see, this one is a 3-membered saturated ring containing 2 heteroatom. First one is oxygen, after that a nitrogen. So according to the last conclusion, that first we are going to use oxygen, we are going to prefer oxygen for that. So first I have written it oxa, after that nitrogen is aza, so here is aza. And 3-membered saturated ring, so I am going to use suffix as a iridine, so its combined name will be oxaziridine. Okay, after that, next see, this one is a 5-membered unsaturated ring containing 2 heteroatom, that is the sulfur and nitrogen. Sulfur is at first position, first we are going to prefer sulfur, so I have written 1. After that, on third number there is a nitrogen, so 1 3, sulfur for thia, and nitrogen azo. So aza, that is Az will represent the nitrogen atom, and Thi will represent the sulfur atom. Okay, and OLE is your suffix which we are going to use for a 5-membered unsaturated compound. So its combined name will be 1,3-thiazole. We can also call it as a thiazole. We cannot at here we are not showing the position of that compounds heteroatoms, that is 1 and 3. One number it is sulfur, and third number it is a nitrogen. After that, next it is an 6-membered ring, unsaturated ring. Okay, so its suffix will be ine. After that, there are 3 heteroatom, nitrogen and 2 sulfur atoms, right? So first we have to go for the nomenclature. Okay, first we are going to give a numbering to this compound. Okay, let's see. If I start from here, that is 1 for sulfur, after that second for nitrogen, third for this carbon atom, 4 for this sulfur atom, 5 and 6. This one will be our naming. Okay, so first number, after that 4 number there is a sulfur, after that second number there is a nitrogen. There are 2 sulfur atoms, so I'm going to write dithia, that is di means 2, and thia means sulfur atom. After that, there is 1 nitrogen atom, so I am going to write Az, that is aza. Okay, and ine is your suffix for 6-membered unsaturated ring. So your combined name will be 1,4,2 dithiazine. Okay, let's see the next. This one is also an 6-membered heterocyclic ring. An unsaturated ring which contain 2 heteroatom. First one is your oxygen and second one is your nitrogen. As we said, we are going to prefer oxygen first, so we will start naming from the oxygen, that is 1, then 2, 3 and 4 number will be your nitrogen. So 1 and 4 oxa for oxygen, after that Az for nitrogen, and the ending of the ring will be ine because it is a 6-membered unsaturated ring, so its name will be 1,4-oxaazine. Okay, next it is a substituted 5-membered heterocyclic ring. Okay, let's see, there are 3 heteroatom, 2 nitrogen atom are there and 1 oxygen atom are there. So we are going to start numbering from the oxygen, as we said that we are going to prefer oxygen first. So I will start the numbering from oxygen. After that, second one is the nitrogen, third one will be this carbon, after that this nitrogen will be fourth, and this carbon will be fifth. If you are able to see, there is a one substituent which is a chlorine, and second one is a methane. Okay, here will be a CS3 group will be there, so it is a methane. So as we know about the IUPAC nomenclature, first we have to numbering that ring. Okay, as we said that we numbered it. Okay, after that next we have to go for the substituent, the alphabets of the substituent. If we compare chlorine and methane, that C will come first and methane will be the next. Okay, so on the third number of carbon atom there is a chlorine, so I write 3 chloro. After that on the 5 number of carbon atom there is a methane group, so I am going to write 5 methyl. After that I have to write the position of the heteroatom, that is 1, after that 2 and 4. Oxa for oxygen, diazole because of there are 2 nitrogen atoms, so I write it di. Aza means don't 2 nitrogen atoms, and the ending ole will indicate that the ring is 5 membered and unsaturated ring. So its final name will be 3 chloro 5 methyl 1,2,4 oxadiazole. Okay, next one is the common names. Okay, the second names, that is a common name. First, there are large number of important ring systems which are named widely known with their non-systematic, or we can also call it as a common name or a tribal names. Okay, there are for some example. First one is a 5-membered heterocyclic ring containing an oxygen as a heteroatom. We will call it as a furan. After that, 5-membered ring containing sulfur as a heteroatom, we will call it as a thiophene. After that, again 5-membered heterocyclic ring containing nitrogen as a heteroatom, called as a pyrrole. And 6-member heterocyclic ring containing nitrogen, it will called as a pyridine. Okay, let's go with the naming of heterocycles with fused ring system. If we have a fused ring compounds, then how we are going to name that heterocycles, we are going to see it at here. First, when naming such a compound, the side of the heterocyclic ring is labeled by the letter A, B, C, etc. So we have to start it with A, B, C. Okay, like this. After that, starting from the atom numbered 1, therefore side A being between atom 1 and 2, side B between atom 2 and 3, and so on, as shown on the pyridine, as you can see at here. Okay, after that the name of a heterocyclic ring is chosen as a parent compound, and the name of the fused ring is attached as a prefix. The prefix in such a has a ending O, then we will call it as a benzo. Let's see some examples. There are 2 rings. First one is your 6-member ring and 5-member ring. So as we said, we are going to give its name like A and B. A is your 5-member ring and B is nothing but your 6-member ring. So 6-member ring is nothing but your benzene ring. So we are going to write benzo, after that B, and this one is your furan ring. As we say that in a common name, that is this one is an furan ring. So its name will be benzo B furan. Okay. Next, see, there are the both are 6-member ring. First one is your benzene, so we are going to write benzo. After that B, and this one, this 5-member ring with nitrogen atom is called as a pyridine. So its name will be benzo B pyridine. Next one, again 6-member ring and 5-member ring. 6-member ring is nothing but your benzene ring. So we are going to write benzo. After that C and thiophene. Why? Because there is a sulfur atom containing a sulfur atom which is containing in a 5-membered unsaturated heterocyclic ring. So its name is a thiophene. So its combined name will be benzo C thiophene. Next one, let's see, there is one 6-member ring and 8-member ring. So it is an benzo D thiopine. Okay. Next one, third nomenclature system, that is the replacement nomenclature. In replacement nomenclature, what happened? The heterocycles names is composed of the carbocycles names and a prefix that denotes the heteroatom. Thus, aza, oxa, and thia are prefixes for nitrogen ring and oxygen ring atom, and thia is for sulfur ring atom. Heterocyclic rings are possible number. Okay, let's see some examples. First one is your oxacyclopropane. As we know that 3-membered ring and cyclic ring, then we called it as a cyclopropane, but there is a one oxygen atom, so we are going to indicate it as a oxacyclopropane. Okay, we can say it as a oxidine or ethylene oxide also. Okay, next see, this one is a 4-membered ring. 4-membered ring is called as a cyclobutane, but there is one oxygen atom, so I'm going to indicate it as a oxacyclobutane or oxetane. After that, next one, 5-membered ring containing one heteroatom, that is oxygen. So its name will be oxacyclopentane or tetrahydrofuran. Okay, it is also used as a solvent in so many reactions. After that, this one is again a cyclopropane ring containing sulfur as a heteroatom. So we are going to write it as a cyclopropane or thiene. Okay, there are some examples. First one is again cyclopropane ring. So, and there is one nitrogen atom. So we are going to write it as a azacyclopropane or aziridine. After that, 4-membered ring, that is cyclobutane ring. There is one nitrogen atom. So azacyclobutane or aziridine. Next one, 5-membered ring. 5-membered means what? It will be an cyclopentane ring. And there is one nitrogen atom as well as there is one substituent. Here will be a methyl group will be present. So its naming will start from this nitrogen atom. This carbon will have a second number because it has a substituent. So that second carbon atom has a methyl group. So its name will be 2-methyl azolidine or 2-methyl azacyclopentane. Next one is a 6-membered ring. 6-membered ring is called as a cyclohexane containing one nitrogen atom and one substituent. Here your CS3 will be there, right? So starting from the nitrogen numbering, so nitrogen has a first number, this carbon has a second number. So its name will be 2-methyl azacyclohexane or 2-methyl piperidine. After that, next one is again 5-membered ring. 5-membered ring is called as a cyclopentane ring. There is one nitrogen atom and ethylene as your substituent. Okay, so we are going to write, and that substituent is present on the nitrogen atom. So here we are going to start the naming with the nitrogen atom. We will write it as N-ethyl azacyclopentane or N-ethyl pyrrolidine. Okay, thank you.